Hello, and welcome to Boring History for Sleep. Tonight, we will be examining an object of remarkable consistency. An object designed to fall, yet engineered with a precision that rivals scientific instruments. Consider the modern bowling pin. 10 identical soldiers standing in a perfect triangle, awaiting their momentary, thunderous dispersal. We take their uniformity for granted. A pin in a San Diego alley is, for all intents and purposes, identical to one in Bangor, Maine. This sameness is the very bedrock of the sport. But this was not always the case. There was a time when these wooden sentinels were wildly unpredictable, their dimensions and disposition changing from one town to the next. To truly understand the quiet revolution that made a national pastime possible, we must turn back the clock and examine the meticulous, painstaking process of its origins. The story of the standardized bowling pin begins not with a flash of invention, but with a slow, creeping sense of dissatisfaction. In the America of the late 1880s and early 1890s, the game of 10-pin bowling was a fractured and chaotic affair. It was a popular activity, certainly, found in the basements of saloons, in private athletic clubs, and in dedicated public alleys that were beginning to spring up in major cities. Yet, the game a person played in Chicago was often fundamentally different from the one played in New York or Philadelphia. This inconsistency was not just a matter of local rules or customs, it was embedded in the very wood of the equipment. There was no central authority, no governing body to dictate the proper length of a lane, the acceptable weight of a ball, or, most critically, the exact size, shape, and weight of a bowling pin. Consequently, the pins of this era were a motley crew. They were creations of local craftsmen, turned on lathes by woodworkers who relied on their own eye, a few rough measurements, and the particular characteristics of the wood they had on hand. An alley owner in Milwaukee might commission a set of pins from a local furniture maker who would turn them from Wisconsin maple. Another proprietor in Boston might use a different craftsman who perhaps favored birch. The result was a startling lack of uniformity. A set of pins in one establishment might be tall and slender, with a high center of gravity that made them fall at the slightest touch. A few blocks away, another alley might feature pins that were short, squat, and bottom-heavy, stubbornly refusing to topple unless struck squarely. The wood itself was a source of endless variation. While hard maple was generally preferred for its durability, the specific qualities of the wood were left to chance. A pin turned from a dense, slow-growth sugar maple would behave very differently from one carved from a faster-growing, less dense species. Even within a single set of 10 pins, turned from the same batch of lumber, there could be significant differences in weight and balance due to natural variations in the wood's density. Some pins were lively, seeming to leap into their neighbors upon impact, while others were dead, absorbing the ball's energy with a dull thud and falling with little collateral effect. This chaos had profound implications for the game. For the bowler, it meant that skill was not easily transferable. A high-scoring champion of a particular Chicago alley might travel to New York for a match, only to find himself utterly baffled by the local equipment, his finely honed hook rendered useless against an unfamiliar set of squat, heavy pins. Scores were, therefore, almost meaningless outside the context of a single location. A score of 200 in one alley might be a monumental achievement, while in another, with a set of light and wobbly pins, it could be a commonplace occurrence. This made any attempt at national record-keeping an exercise in futility. More insidiously, the lack of standards opened the door to chicanery. Unscrupulous alley proprietors could manipulate the game for their own benefit, particularly when gambling was involved. A house bowler might be accustomed to a specific set of doctored pins, giving him an almost insurmountable advantage against an unsuspecting visitor. Pins could be weighted at the bottom with lead plugs to make them harder to knock down, or they could be deliberately made of lighter wood to inflate scores and create a false sense of excitement. Accusations of cheating were common, and disputes often soured the recreational atmosphere of the sport. The dream of bowling as a legitimate, respectable contest of skill was being held back by 10 pieces of wood. It was in this environment of disarray that a group of dedicated bowling enthusiasts recognized the need for order. They were proprietors, bowlers, and businessmen who envisioned a future for the sport that transcended the local saloon. One of the key figures in this movement was Joe Thumb, a prominent New York City restaurateur and bowling proprietor. He, along with others from various bowling clubs in the city, saw that for the game to grow, to attract a better class of patrons, and to host legitimate tournaments, there had to be one set of rules, one standard for all. After several preliminary meetings and much correspondence, a pivotal gathering was held on September 9, 1895, at Beethoven Hall in New York City. Delegates from various bowling leagues and clubs came together with a singular purpose: to establish a national governing body for the sport of American tenpins. From this meeting, the American Bowling Congress, or ABC, was born. Its mission was clear: to create and enforce a uniform set of rules and equipment specifications that would apply to every sanctioned lane in the country. This marked the beginning of the end for the era of the backyard-made, anything-goes bowling pin. The meticulous, decades-long journey toward standardization had begun. The fledgling American Bowling Congress understood that its primary task was to bring order to the chaos of the lanes. While rules of play were debated and codified, the committee members knew that uniform rules were meaningless without uniform equipment. The bowling pin, as the central target of the game, was the first and most crucial piece of equipment to be addressed. The challenge was immense. They had to devise a specification for a pin that would be fair, durable, and capable of being mass-produced with a reasonable degree of consistency. Furthermore, the design they chose would have to strike a delicate balance. It needed to be challenging enough to reward skill, but not so difficult as to discourage the average player. The committee tasked with this job did not work in a vacuum. They drew upon the existing, albeit varied, traditions of pin design. The two most prominent styles of the day were often referred to as the New York pin and the Chicago pin. The New York style tended to be slightly more slender, while the Chicago style was generally thicker in the belly. The committee had to mediate between these and other regional preferences to arrive at a compromise that could be accepted nationally. Their deliberations involved examining dozens of different pins, measuring them, weighing them, and, most importantly, observing how they behaved in play. After much discussion, the ABC published its first set of official equipment specifications in the late 1890s in preparation for the first truly national tournament they planned to host. These initial standards were a monumental step forward, but by modern measures, they were still quite broad. The first official ABC pin was mandated to be 15 inches in height, a dimension that has remained unchanged to this day. The maximum diameter at the belly of the pin was set at 4.5 inches. The base was to be no less than 2 inches and no more than 2.25 inches in diameter. The weight specification was perhaps the most telling indicator of the manufacturing capabilities of the era. The rules stated that a pin should weigh between 3 pounds and 3 pounds 8 ounces. This 8-ounce variance seems enormous today, but it was a practical concession to the inconsistencies of wood and the limitations of hand-turning production methods. The material was specified simply as clear hard maple, a term that, while pointing in the right direction, left a great deal of room for interpretation. The real test of these new standards, and the catalyst for their widespread adoption, was the inaugural ABC National Tournament, held in Chicago in 1901. For this event, it was imperative that every lane be equipped with pins and balls that met the new ABC regulations. The ABC contracted with the Brunswick Balk Colander Company, already a dominant force in the manufacturing of billiard tables and bar fixtures, to produce the official pins for the tournament. This was a crucial partnership. Brunswick had the industrial capacity to produce thousands of pins that adhered to the new specifications, something local craftsmen could not do. The success of the 1901 tournament was a turning point. Bowlers from across the country competed on a level playing field for the first time. The event generated national publicity and lent an unprecedented air of legitimacy to the ABC and its rules. Alley proprietors who wished to host their own ABC-sanctioned leagues and tournaments, and thus attract serious bowlers, had a powerful incentive to upgrade their equipment to meet the official standards. The ABC's power lay in its ability to sanction or withhold sanctioning. If an alley's pins were not compliant, it could not be part of the official, organized sport. This was the primary mechanism for enforcing the new order. Manufacturers like Brunswick, in turn, saw a tremendous business opportunity. Standardization simplified their production lines. Instead of making dozens of different regional pin styles, they could focus on producing one official ABC-approved model in massive quantities. They began to market their pins aggressively, advertising them as official ABC regulation pins. For an alley owner, purchasing a set of these pins was not just an equipment upgrade. It was a mark of legitimacy, a signal to customers that their establishment offered a fair and modern game. Despite this initial success, the early standards soon revealed their shortcomings. The 8-ounce weight range was still too wide. A bowler could play one game with a set of pins averaging close to 3 pounds, and the next game with a set averaging 3 pounds 8 ounces, and the difference in scoring would be dramatic. Furthermore, the simple designation of clear hard maple did not address the critical issue of wood density. The ABC's work was far from over. The first great leap had been made, moving from pure chaos to a basic framework of order. The next phase of the journey would be a descent into the microscopic details of wood science, a quest for a level of consistency that early pioneers could hardly have imagined. As the sport of bowling grew in popularity through the 1910s and 1920s, the limitations of the initial ABC specifications became increasingly apparent to serious bowlers and diligent scorekeepers. While the dimensions of the pins were now largely uniform, their performance on the lanes was not. The crux of the problem lay in the wood itself. The rule simply called for clear, hard maple, but this was a deceptively simple designation for a complex natural material. Hard maple, primarily the species Acer saccharum or sugar maple, grows across a wide swath of eastern North America. The specific characteristics of the wood, its density, its hardness, its grain structure, are influenced by the climate, the soil, and the altitude where the tree grows. Maple harvested from the cold, slow-growing forests of the northern Great Lakes region, for instance, tends to have a tighter grain and a higher density than maple grown in the more temperate climates of the Appalachian region. This variation in density was the hidden variable that plagued the game. Two pins could be turned to the exact same dimensions, both measuring a perfect 15 inches in height and 4.5 inches at the belly. Yet if one was made from a dense piece of northern rock maple and the other from a lighter piece of Appalachian maple, their weights would differ. More importantly, their centers of gravity and moments of inertia would be different. In the simple, practical terms of the bowler, this meant that some sets of pins were lively or active, while others were dead or heavy. A lively set of pins, typically lighter and with a slightly higher center of gravity, seemed to explode on impact. They would fly into each other, creating a chain reaction that resulted in more strikes and higher scores. A dead set, made of denser wood, would absorb more of the ball's energy. The struck pin would often just slide or fall straight back, failing to take its neighbors with it. This led to frustratingly stubborn corner pin leaves, like the 7-pin or the 10-pin. Bowlers would complain that one alley had good wood, while another had bad wood. Records and averages were still not truly comparable from one sanctioned house to the next. The American Bowling Congress, committed to its mission of fair and uniform play, recognized that it had to address this subtle but significant problem. The solution required a more scientific approach. Around this time, the ABC established a formal equipment testing and research committee. This group was composed of engineers, manufacturers' representatives, and experienced bowling officials. Their mandate was to delve deeper into the physical properties of the bowling pin and refine the specifications to eliminate as much variability as possible. The committee's work began with extensive data collection. They solicited pin samples from manufacturers and alleys across the country. These pins were brought to laboratories where they were subjected to a battery of tests. They were precisely measured with calipers and micrometers. They were weighed on sensitive scales. Their center of gravity was located. The committee began to build a database correlating these physical properties with on-lane performance. One of the first and most important refinements to the specification was to narrow the acceptable weight range. Through the 1920s and into the 1930s, the ABC gradually tightened the tolerance. The 8-ounce range was slowly reduced to 6 ounces, then to 4. This forced manufacturers to be much more selective about the wood they used. The committee also began to specify the wood in greater detail. The rule was amended from the generic, clear hard maple to northern hard rock maple, explicitly favoring the denser, more consistent wood from the northern regions. Furthermore, they introduced standards for the seasoning and drying of the lumber. The moisture content of the wood became a critical specification. Wood that is too wet is heavy and soft. Wood that is too dry is light and brittle. The ideal bowling pin needed a precise equilibrium of moisture, typically between 6 and 8%. To achieve this, manufacturers had to adopt more sophisticated kiln drying techniques. The process of drying maple for bowling pins became a science in itself. The raw lumber, cut into rectangular blocks called billets, would be carefully stacked in massive kilns. Over a period of several weeks, the temperature and humidity inside the kiln would be meticulously controlled according to a predetermined schedule. The heat would be raised gradually to drive the moisture out of the wood cells, while carefully controlled humidity prevented the surface of the wood from drying too quickly, which could cause cracking and checking. This slow, patient process ensured that each billet reached the target moisture content uniformly, from its surface to its core. Another challenge that arose was the scarcity of large, flawless blocks of maple required to turn a pin from a single piece of wood. As demand for pins surged, it became difficult to find enough virgin timber of sufficient diameter. This led to the development of the laminated pin block. Manufacturers began to construct the raw billets by gluing together several smaller blocks of hard maple. This innovation, born of necessity, introduced a whole new set of variables that the ABC had to control. If not done properly, a laminated pin could be weaker than a solid wood pin, and the glue lines could fail under the repeated impact of the bowling ball. The ABC Equipment Committee responded by creating a new set of rules specifically for laminated pins. They specified the number of pieces allowed, typically no more than 7. They dictated the orientation of the grain in each piece, requiring that it run vertically, parallel to the pin's height, to ensure maximum strength. They even began to regulate the type of adhesive used, favoring new waterproof resin glues that could create a bond stronger than the wood itself. The process of turning the pin also became more standardized. While early pins were turned by hand, the major manufacturers developed sophisticated automatic lathes. A rough-cut, glued-up billet would be placed in the machine. A series of cutting knives, following a master template, would automatically shape the pin to the precise ABC-specified contours in a matter of seconds. This removed the element of human error and ensured that every pin coming off the line had the same profile, from the gentle curve of the belly to the narrow taper of the neck. By the early 1930s, the bowling pin was evolving from a craftsman's product into a highly engineered piece of sporting equipment. The ABC's relentless pursuit of uniformity had pushed manufacturers to adopt more scientific methods and tighter quality controls. The focus had shifted from just the outward dimensions to the internal, invisible properties of the wood itself, its density, its moisture content, and its construction. The era of the truly standardized pin was dawning, an age of precision that would form the bedrock of bowling's golden age. The period from the mid-1930s through the 1950s can be considered the golden age of bowling pin standardization. During these years, the American Bowling Congress, in close cooperation with major manufacturers like Brunswick and AMF, refined the specifications for the bowling pin to a degree of precision that was extraordinary for a piece of sporting equipment made from a natural material. The goal was simple yet ambitious: to ensure that a bowling pin's performance was so consistent that the outcome of a game depended solely on the skill of the bowler, not on the quirks of the equipment. The physical dimensions of the pin were locked into a very tight set of tolerances. The official height remained, as always, 15 inches, but now a tolerance of plus or minus 1/30th of an inch was applied. The belly, or the widest part of the pin, was specified to be 4 and 49/64 inches in diameter. The base was set at 2¼ inches. The neck, at its narrowest point, was to be 1 and 49/64 inches. These seemingly arcane fractions were not arbitrary. They were the result of years of on-lane testing and analysis, calculated to provide the optimal balance between scoring and difficulty. The weight specification was also significantly tightened. The acceptable range was narrowed to between 3 pounds 6 ounces and 3 pounds 10 ounces. This 4-ounce window was a dramatic improvement from the 8-ounce variants of the early days. To achieve this consistency, manufacturers had to implement rigorous quality control measures at every stage of production. Let us follow the journey of a single bowling pin through a state-of-the-art manufacturing plant of this era, such as the Brunswick facility in Muskegon, Michigan. The process began with the arrival of raw lumber, train cars full of northern hard rock maple billets, already rough-sawn to the approximate size, would arrive at the factory. The first step was inspection. Each billet was visually inspected for defects like knots, cracks, or irregular grain patterns. Only the highest grade, clear maple, was accepted for the production of ABC-approved pins. The accepted billets were then sent to the kilns. As we discussed, the kiln drying process was critical. Technicians would monitor the multi-week drying schedule with scientific precision, using probes to check the internal moisture content of the wood. After emerging from the kiln and stabilizing at the target moisture level, the billets were ready for the gluing process. Skilled workers would select several kiln-dried blocks, carefully orienting their grain patterns to ensure maximum strength and uniformity in the final glued-up billet. A waterproof resin glue, often a urea formaldehyde adhesive, was applied, and the blocks were clamped together under immense pressure in a hydraulic press. To speed up the curing of the glue, many factories adopted a new technology, radiofrequency heating. The clamped billets would be passed through an electromagnetic field, causing the water molecules in the glue to vibrate rapidly, generating heat and curing the adhesive in a matter of minutes rather than hours. Once the glue was cured, the laminated billet, now a solid, stable block of wood, was sent to the turning department. Here, the magic of mass production took shape. The billets were fed into automatic backknife lathes. A worker would clamp a billet into the machine. The lathe would spin the billet at high speed, and a set of cutting knives, guided by a steel template ground to the exact profile of an ABC regulation pin, would advance and shape the wood. In a shower of sawdust and wood shavings, the rectangular block was transformed into the familiar, curved silhouette of a bowling pin in less than a minute. From the lathe, the newly turned pin, still in its raw wood state, moved on to the finishing department. This was a multi-step process designed to protect the wood and provide a smooth, durable surface. First, the pins were run through a series of sanding machines with progressively finer grits of sandpaper, rendering their surface perfectly smooth. Then, they were submerged in a sealing solution to close the pores of the wood and prevent moisture from being absorbed. After sealing, the pins entered the paint room. The iconic white lacquer finish was applied, often through a process called flow coating, where the pin was passed through a curtain of falling lacquer to ensure a perfectly even coat. Several coats of this base lacquer were applied, with sanding in between each coat. The distinctive red stripes on the neck were then added. These were not merely decorative. Their size and placement were also part of the ABC specification, serving as a visual reference point for the bowler and officials. The final step in the finishing process was the application of the ABC logo. This was more than just branding, it was a seal of approval. A decal bearing the American Bowling Congress logo was carefully applied to each pin. This mark certified that the pin had been manufactured in accordance with every one of the ABC's stringent specifications. It was a guarantee of fairness and uniformity. Throughout this entire process, from raw lumber to finished product, quality control inspectors were a constant presence. They would pull random billets to check moisture content. They would test the strength of the glue bonds. They would use templates and calipers to check the dimensions of the turned pins at various stages. Most importantly, every single finished pin was weighed. A pin that fell outside the narrow £3 6-ounce to £3 10-ounce window was rejected. It might be sold as a second for novelty purposes, but it would never receive the coveted ABC stamp. But how did a manufacturer get its pin model approved by the ABC in the first place? This was a formal and rigorous process. A company wishing to produce and sell official pins had to submit a number of samples, typically several dozen, to the ABC Equipment Committee for testing. The committee's laboratory would first verify all the physical specifications. The pins would be measured, weighed, and their center of gravity would be precisely located. They might even be cut open to inspect the quality of the lamination and the grain structure. If the pins passed these physical inspections, they moved on to the most important test, on-lane performance. The sample pins were sent to a designated test facility, an ordinary bowling alley that worked with the ABC. There, the pins would be put into actual play for hundreds, sometimes thousands of games. The ABC would monitor scoring data produced with the new pins. They were looking for consistency. Did the pins produce scores that were in line with established averages? Did they have the right action? This concept of action, or scoreability, was somewhat subjective, but critically important. The committee was trying to quantify the pin's liveliness. A key metric they began to study was the coefficient of restitution. In simple terms, this is a measure of how bouncy the pin is. It represents the ratio of the final to initial relative speed between two objects after they collide. The committee would conduct drop tests, releasing a steel ball from a fixed height onto the belly of a pin and measuring how high the ball bounced. A pin with too high a coefficient of restitution would be deemed too livelier, sending pins flying in an unpredictable manner and potentially leading to inflated scores. A pin with too low a value would be dead, leading to lower scores and frustrated bowlers. The ABC established a narrow range for this property, and a manufacturer's pins had to fall within it to gain approval. Only after a pin model had passed this entire battery of tests, dimensional, weight, material, construction, and performance, would the ABC grant its official sanction. The manufacturer could then apply the ABC logo and market their product as a regulation pin. This meticulous, multi-layered system of specifications and testing ensured that by the 1950s, the 10 pins standing at the end of a lane in any sanctioned house in America were, for all practical purposes, interchangeable. The quiet, unseen work of the committees and engineers had created a level playing field on a national scale, allowing the sport to flourish as a true test of human skill. The post-World War II era saw a massive boom in the popularity of recreational bowling in America. Suburbanization, increased leisure time, and a growing middle class fueled the construction of new, modern bowling centers across the country. A pivotal technological innovation accelerated this growth: the invention and widespread adoption of the automatic pin setter. First introduced by AMF in 1951 and followed shortly by Brunswick's Pin Spotter, these amazing machines eliminated the need for human pinboys, making the game faster, more efficient, and more appealing to families. However, this mechanical revolution placed new and unforeseen stresses on the meticulously standardized bowling pin. A human pinboy, for all his inconsistencies, generally handled the pins with a degree of care. He would lift them and place them gently into the rack. The new automatic pin setters were machines of steel and force. The sweep bar would unceremoniously knock deadwood into the pit. The pins would be lifted, jostled, and slammed into place by mechanical arms. The number of games played on a single lane in a day skyrocketed, and the wear and tear on the pins increased exponentially. The beautiful, multi-layered lacquer finish, so carefully applied at the factory, was no match for this new, harsh environment. The lacquer would quickly chip, crack, and wear away, especially around the belly of the pin where it absorbed the most impact from the ball and other pins. The wood underneath would become exposed, dented, and compressed. This wood-on-wood impact caused the pins to degrade rapidly. Their performance changed as they aged. A fresh, new set of pins would have a different action than a set that had been in use for a few months. For bowling center proprietors, this was a major operational and financial headache. To maintain a consistent playing condition, they had to rotate their sets of pins frequently. Worn pins had to be taken out of service and sent to be refinished, a costly and time-consuming process that involved stripping off the old lacquer, filling in dents, sanding, and then reapplying the multiple coats of finish. This constant maintenance was a significant expense, and it drove manufacturers and the ABC to search for a more durable solution. The first attempts at a more resilient coating involved early forms of plastic. Manufacturers began experimenting with ethyl cellulose, a thermoplastic material that could be applied as a thick, clear coat over the traditional lacquer. This added a layer of protection and extended the life of the pin's finish, but it was not a perfect solution. The bond between the cellulose coating and the lacquer base could sometimes fail, causing the coating to peel or delaminate. The true breakthrough came from an unlikely source, the chemical giant DuPont. In the mid-1950s, DuPont developed a new type of ionomer resin, which they branded with the name Surlyn. It was an incredibly tough, resilient, and abrasion-resistant thermoplastic. Originally developed for applications like golf ball covers and packaging films, someone in the bowling industry saw its potential as the ultimate coating for a bowling pin. The transition from a painted lacquer finish to a solid plastic coating represented the most significant change in bowling pin manufacturing since the adoption of the laminated wood core. It required a complete re-engineering of the production process. The old method of painting and finishing was discarded. In its place came a new process, compression molding. In this new method, the turned maple core was produced in much the same way as before, but it was made slightly smaller in diameter to account for the thickness of the coming plastic shell. The raw wood core was then placed inside a two-part steel mold, which was precision machined to the final, exact dimensions of an ABC regulation pin. Pre-measured pellets of the Surlyn resin were placed into the mold around the wood core. The mold was then heated and subjected to immense pressure. The heat melted the Surlyn pellets, and the pressure forced the molten plastic to flow into every crevice, forming a seamless, uniform shell around the wood core. The plastic bonded directly and permanently to the wood, creating a single, integrated unit. The first plastic-coated pins, introduced in the late 1950s, were a revelation in terms of durability. They could withstand the relentless punishment of automatic pin setters for thousands of games with little visible wear. The finish wouldn't chip or crack like lacquer. They were also easier to clean, retaining their bright white appearance for much longer. For proprietors, this was a revolutionary improvement, drastically reducing maintenance costs and ensuring a more consistent playing surface for their customers. However, this new technology presented a major challenge for the American Bowling Congress. The Committee on Equipment had to go back to the drawing board. A plastic-coated pin was a fundamentally different object from its lacquered predecessor. The committee had to determine if it performed the same way. A whole new round of testing and specification adjustments was required. The first issue was weight and balance. The plastic shell was denser than the lacquer it replaced. To keep the total weight of the pin within the 3 pound 6 ounce to 3 pound 10 ounce specification, the maple core had to be made slightly lighter. This meant using a slightly less dense grade of maple or subtly altering the core's dimensions. The location of the pin's center of gravity was also affected by the addition of the uniform plastic shell, and manufacturers had to adjust their core designs to ensure the new pins had the same balance point as the old ones. The most critical performance characteristic to be re-evaluated was the coefficient of restitution. The tough, resilient Surlyn shell was inherently bouncier than a lacquer finish. The first prototypes of plastic-coated pins were found to be far too lively. They would bounce off the lane's kickbacks and each other in wild, unpredictable ways, leading to unusually high scores and strange pinfall patterns. The game's integrity was at stake. The ABC and the manufacturers worked together to solve this problem. The solution lay in fine-tuning the formulation of the plastic itself and in the design of the wood core. By adjusting the chemical composition of the Surlyn resin, they could control its rebound properties. They also found that they could dampen the pin's action by altering the shape of the wood core underneath the plastic, creating a composite object whose total performance matched the long-established standard of the lacquered woody. An amusing but important side effect of the plastic revolution was the change in the sound of the strike. Bowlers had been accustomed to the sharp, resonant crack of lacquered maple pins colliding. The new plastic-coated pins produced a duller, more muted thud. Many long-time bowlers complained, feeling that the new sound lacked the satisfying authority of a true strike. This was not just a matter of aesthetics. For many serious bowlers, the sound of the pins was an important form of auditory feedback. Manufacturers actually spent considerable time and resources trying to tune the sound of their new pins. They experimented with different plastic formulations and core designs, not just to control the pin's bounce, but to try and replicate the classic sound that bowlers cherished. By 1960, the transition was largely complete. The ABC had developed a new, comprehensive set of specifications for plastic-coated pins, and they had become the industry standard. The meticulous process of standardization had successfully navigated a major technological shift. The journey that had begun in a New York hall in 1895, with a group of men trying to impose a basic order on a chaotic pastime, had culminated in a piece of sporting equipment engineered to a remarkable level of scientific and manufacturing precision. From the hand-turned, highly variable wooden clubs of the 19th century to the plastic-encased, scientifically balanced objects of the mid-20th century, the evolution of the bowling pin is a story of quiet, incremental progress. It is a narrative driven not by dramatic events, but by the patient work of committees, the ingenuity of engineers, and the relentless pursuit of a simple, powerful idea: a fair game. Every arcane fractional measurement, every specification for wood density and moisture content, every rule governing the lamination of the core and the rebound of the shell, was a small step toward that ideal. This meticulous standardization transformed bowling from a regional game of chance into a respected national sport, a pastime where millions of people could compete on equal footing. And so, the next time you stand at the approach, watching the 10 gleaming white pins standing in perfect formation 60 feet away, you can appreciate the decades of quiet, painstaking history that made their uniformity possible. They stand there silent and ready, a testament to the beauty of a well-defined standard.